Hey everybody, welcome in. Today we're going to be taking a look at uh, Engage New York, Eureka Math's grade 4, Module 1, lesson number 16. And in this lesson, we're going to be looking at solving two-step word problems using the subtraction algorithm, modeling with tape diagrams, and then using rounding to assess the reasonableness of our answer. So couple different skills in here that we want our students to be competent with. So let's go ahead and we can dive in. Number one, the directions read, estimate first and then solve each problem, model the problem with a tape diagram, explain if your answer is reasonable. And each one of these questions is broken up into three parts, an A, B, and a C. So we'll go ahead and start with number one, where it says, on Monday, a farmer sold 25,196 pounds of potatoes. On Tuesday, he sold 18,023 pounds. On Wednesday, he sold some more potatoes. And then in all, he sold 62,409 pounds of potatoes. Letter A says, about how many pounds of potatoes did the farmer sell on Wednesday? Estimate by rounding each value to the nearest thousand, then compute. So a lot of information in just these four lines here. So let's go back and read again. It says, on Monday, a farmer sold 25,196 pounds of potatoes. On Tuesday, he sold 18,023 pounds. And on Wednesday, he sold some more potatoes. So when I read that, what I realize is we know how many pounds were sold on Monday. We know how many pounds were sold on Tuesday, but we don't know how many were sold on Wednesday because it says he sold some more potatoes, so some amount. But we do know that all in all, in total or in all, he sold 62,409 pounds of potatoes. So we can certainly work with this information. Letter A says, about how many pounds of potatoes did the farmer sell on Wednesday? So that's what we need to figure out. We need to figure out this mystery number of how much he sold on Wednesday, because remember, the problem doesn't tell us. We're going to start by estimating first. We're going to estimate by rounding each value to the nearest thousand, and then we can go ahead and do our arithmetic. So let's go ahead and start by rounding each of these. So on Monday, he sold 25,196 pounds. So if I were to round that number to the nearest thousand, I would identify the digit in my thousands place, which is the 5, peek over here at my digit in the hundreds place, and that's going to tell my 5 what to do. Since this is a 1, that 5 is going to stay as is. So 25,196 rounded to the nearest thousand is 25,000. We'll do the same thing for Tuesday. And on Tuesday, he sold 18,023. Same idea. Identify the digit in the thousands place. Peek over at the hundreds, and that'll tell this digit what to do. Since this is a 0, that means we are going to leave the 8 in the thousands place as is. So 18,023 will round to 18,000. Now remember, Wednesday we don't know. That's what we need to figure out. But we know the total. We know in all, which means the combination of Monday, Tuesday, and Wednesday. That will give us our total. So in total, he sold 62,409 pounds, which if we round, that will give us 62,000. So to use a tape diagram to model this, we're going to use our rectangle. And this will be, I'll just use an M for Monday's amount. This will be Tuesday's amount. And then this will be Wednesday's amount. And remember, in all, we have about 62,000 because in this example, we're working with rounded numbers. Monday, we have 25,000. Tuesday, we have 18,000. And again, we don't know Wednesday. So what we're going to do is we're going to combine the Monday and Tuesday amounts, and then we're going to subtract that off of the total of 62,000, and that will leave me with how much or how many pounds of potatoes were sold on Wednesday. So just quick change my color here. So 25,000 plus 18,000. That will give me, again, Monday and Tuesday's combined amount. Then I can subtract it off the total, and I'll be left with Wednesday. So zeros in my ones, tens, and hundreds. I had 2 zeros. 5 plus 8 is 13. Bring down my 3, carry my 1. And they sold 43,000 on Monday and Tuesday, 43,000 pounds. So I'm going to put that up here. So now I just sort of combined these amounts, and now I'm going to take away from the total, and that will leave me with just Wednesday. So 62,000 minus 43,000. 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 0 again. 2 minus 3, I'll have to regroup from my 10,000s place. And now 12 minus 3 is 9. And 5 minus 4 is 1 to make 19,000. So that's the estimated amount for Wednesday. About 19,000 pounds of potatoes were sold on Wednesday. Now in letter B, we're doing the same process, but we just need to use the precise numbers. That's what the directions say. Find the precise number of pounds potatoes sold on Wednesday. So when they use this word precise, that means that we're not using rounded numbers. We want to know the actual real number of pounds of potatoes sold on Wednesday. So we're not going to use these rounded amounts. So again, Monday, we have 25,196 pounds. Tuesday, we have 18,023. Again, Wednesday we don't know. That's what we need to solve for. But I do know the total, which is 62,409. And again, to use the tape diagram, again, this is Monday's amount, which is 25,196. This is Tuesday's amount. Wednesday's amount, we do not know, but we know in all, or in total, there's 62,409. So again, same exact process from A to B. The only difference is I'm using the precise numbers down here for letter B. So again, I'm going to put together Monday and Tuesday's amount, and then whatever that number is, subtract it off the total, and I'll be left with Wednesday's. So again, change my color quick. 25,196 plus 18,023. Again, lining up my place values to ensure that I'm adding ones to ones, tens to tens, all that good stuff. 6 plus 3 is 9. This is a 9. Plus 2 is 11. Let's bring down the 1. Carry the 1 up here. In my hundreds place, 1 plus 1 is 2. 5 plus 8 is 13. And 1 plus 2 plus 1 is 4 to make 43,209. Now again, I'm going to take my total and subtract that number because that's the Monday and Tuesday amount. And that'll leave me with just Wednesday. So 62,409 minus Monday and Tuesday's amount. 9 minus 9 is 0. 0 minus 1, I'll have to regroup. So regroup one of these hundreds for 10 tens. And 10 minus 1 is 9. 3 minus 2 is 1. 2 minus 3, I'll have to regroup. So I'll regroup 6 10,000s for 5 10,000s and 10,000s, and I already have 2. So that makes 12. 12 minus 3 is 9, and 5 minus 4 is 1. So what I'm looking for is this estimated number close to the precise number? And you can see here, it is. 19,000 is our estimated amount. 19,190 is my precise amount. And that's going to lead me down here to letter C, where I'm asked, is your precise answer reasonable? And again, when we're looking at this word reasonable, we want to make sure that our estimated amount is close to the actual amount. In our case, it is. Compare your estimate to A to your answer in B. Write a sentence to explain your reasoning. So in letter C, no actual arithmetic. Here's where we need to explain our work. And we can say, yes, my answer of 19,190 is reasonable. 19,190 rounded to the nearest thousand is 19,000, which was the estimated amount. Again, we want to make sure that whatever we are doing with our actual answer is close to our reasonable answer. This is just a quick way to check to make sure that that we're on the right track with our arithmetic. Let's go ahead and move on to number 2. Number 2 says a gas station had 2 pumps. Pump A dispensed 241,752 gallons. Pump B dispensed 113,916 more gallons than Pump A. So let's go back and read that a second time. So there's 2 pumps. There's Pump A, which is the first one, and it dispensed 241,752 gallons. Pump B dispensed 113,916 more gallons than Pump A. So we really need to pay attention to this right here. More gallons than Pump A. That's going to come into play here in a little bit. It says, about how many gallons did both pumps dispense? Estimate by rounding each value to the nearest 100,000, then compute. So we're going to round each value to the nearest 100,000 and then compute. So Pump A, they come out and tell us. Sure, I'm doing this in this color. So A, they tell us there are 241,752 gallons dispensed. So to round that to the nearest 100,000, identify the digit and the place value being rounded, take a peek over to the digit to the right, and that'll tell you what to do with that rounded amount. So we would round this to 200,000. Oops. Now, Pump B is a little bit tricky here because it's not just 113,916 the way I did with Pump A. It says 113,916 more gallons than Pump A. So to use a tape diagram for that, Pump B dispensed the same amount as Pump A, which is the 241,752, and then some more. 113,916 more than Pump A, which means the same amount as Pump A and then a little bit additional. So really, I'm going to have to add these two amounts together to figure out how many was pumped in Pump A. So I'll estimate here, which is 200,000, which I already did. This number is really just this number here. And I'll need to round 113,916 to the nearest 100,000, which is 100,000. And it says about how many gallons did both pumps dispense. So since these are two-step word problems, that was my first step. I needed to figure out about how many gallons were in pump B, and then I can add it to pump A. So really I need to add these together. 200,000 plus 100,000 equals 300,000. So I can say pump B dispensed about 300,000 gallons. And now for both pumps, I'm just going to add pump A to pump B. And that will give me the total amount. So again, this is A, which is 200,000. B is about 300,000. And to put those together, we would have about 500,000 gallons between both pumps. Okay? Now, letter B says exactly how many gallons did both pumps dispense. So again, same process that we just did in A, part A, I should say, except we're using the actual amounts. We're not using rounded numbers in part B. So pump A dispensed 241,752 gallons. Now again, pump B is not just 113,916 gallons. It is the 241,752 gallons that pump A dispensed and the additional 113,916. And then this additional amount. So first things first, I need to figure out how many gallons pump B dispensed, and I'm going to have to come over here and do some actual addition. So 241,752 plus 113,916. 2 plus 6 is 8. 5 plus 1 is 6. 9 plus 7 is 16. 1 plus 1 is 2. Plus 3 is 5. 4 plus 1 is 5. And 2 plus 1 is 3. To make 355,668. Again, that is just the amount in pump B. So in pump B, there were 355,668 gallons dispensed. Now we need to figure out how many both pumps dispensed. So pump A and pump B. All this work here was just figuring out how many gallons were pumped out by pump B. Now we need to add pump B's amount, which is 355,668 plus A. So 355,668 plus 241,752. Now again, addition is commutative, so it really doesn't matter which number you want to have on top or on bottom. With addition, the order doesn't matter in which you add. So if you set up 241,752 on top and 355,668 on the bottom, you will get the same sum. So 8 plus 2 is 10. 1 plus 6 is 7, plus 5 is 12. 1 plus 6 is 7, plus 7 is 14. 1 plus 5 is 6, plus another 1 is 7. 5 plus 4 is 9. And 3 plus 2 is 5. To make 597,420. So in letter C, where it says assess the reasonableness of your answer, this one doesn't work out quite as nicely as letter A because our estimated amount of 500,000 is much less than 597,420. So our estimate is still decently reasonable, but not quite as much as we would like. So we can say my answer, whoops, again. My answer of 597,420 gallons is a little far from the estimated of 500,000. So take into account what we did up in part A as well. In both instances, we needed to round down. So from 241,000 to 200,000, we had to round down, and we really cut off 41,752. Same thing down here in part B. So we rounded down. So we're really leaving out 13,916. So that really should crop back up when we do our estimated amount. Since we rounded down, our actual amount should be a little bit greater than our estimated amount. So I'll continue by saying my estimate of 500,000 is a little lower than the actual amount of 597,420. When I rounded, I needed to round down, so the actual amount would be more than the estimated